Welcome back to our recorded lessons for this term. We have started our recorded lesson by studying the circle for two videos, and after that we have studied algebra and the first lesson in algebra. Now we will complete what we started in geometry by completing on the circle. Now we will study lesson 3 in circle, the position of the point, a straight line, a circle with respect to a circle. After studying the circle and the basic definitions of the circle, we will complete how can we determine the position of a point, a straight line, a circle with respect to a circle. Now we will start with the circle. I have number 1, the position of a point, a straight line, a circle with respect to a circle. I have some circles like the opposite, and I have some straight lines and a point, and we will learn how to determine the position of a point, a straight line with respect to a circle. First, we will start with the position of a point with respect to a circle. If I have a circle like circle M with radius R, and we said that the circle is named by its center M, and I have a point like A, this point, as you see, is lying outside the circle, we can say that the distance from the center M to the point A is longer than the radius of the circle, so we can say that MA is greater than the radius. Also, we can say that if you moved the radius of the circle, it will be smaller than the distance from the center to the point A. We can say that point A is lying outside the circle if MA greater than the radius. In the second figure, we have the circle M also with radius R. If you plot the point A, but this time on the circle, and we can see that if you draw a line segment from M to A, this line segment is exactly like the radius of the circle. So we can see that the distance from M to A is equal to the distance from M to any point on the circle. That means MA equal to the radius of the circle. So the third figure, I have circle M and I have radius R. We can see that if you plot a point A, this point is lying inside the circle. The distance from M to A is smaller than the radius of the circle, and we can see that also A is lying inside the circle. So I have three cases as you see in the screen. MA greater than the radius, and in this case A lies outside the circle. MA equal to the radius and A is lying on the circle. In the third circle, MA smaller than the radius, and we can say that A is lying inside the circle. Drill number 1, if I have an example like this showing that if A is a point in the plane of a circle with center M and radius 7, complete. If MA equals 10 centimeters, then A spaced with a circle. I want to know the position of the point A with respect to the circle, knowing the distance from A to the center and the radius of the circle. You can see that the distance from M to A is greater than the radius of the circle, so we can say that A is lying outside the circle. After that, we have the second example. If MA equals 7 centimeters, then A spaced with a circle. I have MA, as you see, equals to the radius of the circle, so we can say that A is on the circle. After that, in the third example, we have MA equals 4 centimeters, then A spaced with the circle. I have MA smaller than the radius, then A is lying inside the circle. In the fourth example, we have MA equals 0 centimeters, then A spaced with the circle. We can say that the distance from the center to the point A is equal to 0. So we can say that A didn't move. So we can say that A is lying on the center of the circle. Or we can say that A is the center of the circle itself. Now let's move to another point. It's the surface of the circle. We can say that the surface of the circle is the union of set of points of the circle and the set of internal points that called the surface of the circle. If I have a green surface like this and surrounded by a black surface, a black line like this, so we can say that the union between the black line and the green surface is representing the surface of the circle. After that, we have the circumference of the circle, and we said in the first lesson that the circumference of the circle has two rules. Number one, pi times d. Number two, 2 pi r. And we said also that the ratio between the circumference of the circle and the diameter is constant, and this constant is equal to pi. After that, the second point in our lesson today is the position of the straight line with respect to a circle. I will divide the screen into 3 sections, so you can deduce that we will have 3 cases. In the first case, I have circle M with radius r and bring a straight line like this. This straight line is, as you see, outside the circle. In the second case, I have the circle M and the straight line is cutting the circle. In the third case, I have the straight line and a circle, and this straight line is touching the circle at one point. In the first case, we can see that the straight line is outside the circle. So we can say that the intersection between the straight line and the circle M is equal to phi. And also we can say that the straight line L is outside the circle M. We can say that L is called a distant straight line from the circle. So it's a distant straight line. In the second case, I have the intersection between the straight line and the circle M is equal to 2 points, X and Y. We can say that the straight line intersects the circle M, and L is called a secant straight line. In the third case, we have the straight line intersects the circle M at the point A. So we can say that also the straight line touch the circle. The touching point between the straight line and the circle is A. So we can say that L is called a tangent to the circle. So I have 3 basic concepts: the distant, the secant, the tangent. The distant straight line is that the straight line that lies outside the circle. The secant is the straight line that cuts the circle at 2 points and cuts the surface of the circle at a line segment xy. The third case, or the third basic concept, the tangent. The tangent is the straight line touching the circle at one point. From the first figure, I have MA is the line segment joining between the straight line and the center. We can say that MA is perpendicular to the straight line L. In the second case, also MA perpendicular to the straight line L. In the third case, MA is perpendicular to the straight line L. So we can say that MA is greater than the radius, and in the first case, so we can say that MA is a distant. In the second case, we have MA smaller than the radius, and MA is a secant. In the third case, we can say that MA is tangent to the circle, so the distance from M to A is equal to the radius. In the 3 cases, you have MA perpendicular to the straight line L. So you have the 3 cases at your screen and showing the 3 cases for the straight line with respect to the circle, distant, secant, and tangent. We can say that A is a point of tangency in the third case. So I have a tangent and I have a point of tangency. It's the point of intersection between the tangent and the circle. Let's have a fact. I have a circle M. This circle, from any point on it, you can draw a tangent. Let's draw a tangent at the point A. As you see, the straight line is created from the point A. Let's draw a line segment MA perpendicular to the straight line. So we can say that the tangent of a circle is perpendicular to the radius, but from what? From the point of tangency. So we can say that the tangent is perpendicular to the radius from the point of tangency. So MA is perpendicular to L. After that, we can say that also MA perpendicular to the radius L, and we can say that the straight line which is tangent to the circle is perpendicular to the diameter. So the tangent is perpendicular to the diameter to the radius from the point of tangency. Also, we can have another fact. We have the second fact. The second fact is saying that the two tangents drawn from the end points of a diameter are parallel. So the two tangents drawn from the end points of a diameter are parallel. Let's have drill 2. In drill 2, I have the figure. This figure consists of a circle M and a triangle. We can say that AC is a tangent, DC is a tangent, and XY is a secant. MZ is perpendicular to AC, MD perpendicular to DC, and ME perpendicular to XY. So you can arrange the side lengths descendingly from the greatest to the smallest as MD, MZ, and ME, because MD and MZ are equal in length, because both of them is a radius to the circle. Let's have the third case and the most important case at our lesson today. It's the position of a circle with respect to another circle. We have spoken about the position of the straight line, a point with respect to a circle, but now we will speak about the position of a circle with respect to another circle. Let's have a circle M with radius R1. And let's have a circle N with radius R2. As you see, these two circles are away from each other. So we can say that M and N are two distant circles. They are away from each other. So we can say that the intersection between the surface area of the circle M and the surface area of the circle N is equal to phi. So we can say that also the distance from M to N is greater than R1, greater than R2, and greater than the sum of R1 and R2. So Mn is greater than R1 plus R2 in the case of the distant circles. After that, the second case and the third position, I have the two circles when one of them inside the other. If I have a circle M and a circle N, as you see, circle M is inside circle N. The radius of circle N is R1, R2, and the radius of circle N is R2 and M is R1. I have the two radii. The intersection between the two circles is phi, but the intersection between their surfaces is the smaller circle M. Notice the difference between the intersection between the circles and the surfaces of the circles. When I say this intersection between the circles, I mean the circumference of the circle. But when I say the intersection between the surface of the circle and the surface of the circle, I mean all the area that the circle forms. When I say to you that circle M inside the circle N, we can join between the two centers Mn, and we forgot to say that Mn is named by the line of two centers. Here I have Mn, the line of two centers, is equal to what, or smaller than what? Is smaller than R1 plus R2. After that, I have Mn is equal to 0. If you moved the circle to be on the other circle. So, if you have the two circles, one of them inside the other, and they are congruent, and they are concentric, so we can say that the distance between their centers is equal to 0. After that, the third position, two circles touching externally. The two touching circles externally means that you have two circles, and these two circles are touching each other from a point, only one point. So I have M and N are touching each other externally at the point A, so we can say that A is a point of tangency. The surface area of the circle M intersects the surface area of the circle N at one point that called A. Also, we can say that the line of centers Mn, as you see, equal to the sum of radii R1 and R2. And the point A belongs to the line of centers Mn. So I can say that Mn is equal to R1 plus R2. When you say that Mn R1 plus R2, it means that the two circles are touching externally. We said that the tangent is a straight line touching the circle at one point. If you draw a tangent to circle M and draw a tangent to the circle N, you can see that it's a common tangent for both of the two circles because it passes through the point of tangency A. So the straight line, which is common tangent to the two circles, is perpendicular to the line of centers Mn. And we can say that it's a common tangent. This common tangent, you can deduce that it's perpendicular to the line of centers Mn. So the straight line is perpendicular to Mn. After that, let's have the fourth position. The two circles which are touching internally. We have discussed the touching circles externally. Now we will discuss the touching circles internally. So I have the circle N is the greater circle and circle M is the smaller circle. As you see, the two circles are touching internally at the point A. So the intersection between the two circles, I mean the circumferences, is A, but the intersection between the two surfaces is circle M. And we name A by the point of tangency. And we can say that M and N are two touching internally, joined between the line of centers. You can say that A belongs to Mn and A is lying on the line of centers. Mn here is equal to R1 minus R2. So I have Mn is equal to R1 minus R2, not plus. So I have, in the case of the two touching circles internally, in the two circles that are touching internally, the line of centers Mn is equal to R1 minus R2, as you see. Sorry for the mistake. Here I have the straight line L is a tangent to the circle. So the straight line L is tangent to the circle M and N. So we can say that it's a common tangent for the two circles. So straight line L is a common tangent for the two circles. The fifth case, I have the two circles which are intersecting, and this is an important case, and it's very, very important. If you have two circles like M and N, these two circles are intersecting at 2 points for the circles and an area for the surfaces of the circles. I have A and B are the intersecting points of the two circles, and we can see that AB is a common chord for the two circles. So AB is a common chord for the two circles, and we can see that the line of the line of two centers MN is perpendicular bisector for the common chord AB. And we can say that MN is greater than R1 minus R2, or R2 minus R1 according to the greater, and smaller than R1 plus R2. And here R2 is greater than R1. So you must write the greater radius first to avoid getting a negative length. So I have MN is perpendicular bisector for AB, as you see. So MN is perpendicular bisector for AB. In this case, the two circles are intersecting circles, and MN is line of centers. For questions before this, you must make sure that you understood these cases. Let's revise them again. The position of a point with respect to a circle, outside, inside, on the circle. The position of a straight line with respect to a circle is tangent, secant, distant, and the position of a circle with respect to a circle, touching externally, touching internally, intersecting, one of them inside the other, and concentric circles. With my best wishes, for questions and suggestions, please contact us at the creative 2010 at yahoo.com, or Facebook/hamada tharwat, or phone us at this number. Thank you very much.